In this session, we will control a servo motor. First, connect the module. If you look at the bottom left of the expansion board, you can connect the servo motor here with a total of 4 connections available. The top connections are for ground, VCC, the servo motor, and the signal pin. So, please connect the servo motor wires with brown on top and red in the middle. Since we will only control one this time, you can connect it to X1. You can connect it like this. To control the servo motor this time, you need to install the servo motor library provided by Adafruit. But unlike before, you can't just install it with a single file. There are multiple files. So first, go to this site and click on the code in the GitHub repository, and you can see the download option here. Right. Please simply click here to download the code in a compressed file package. Now that you have downloaded this compressed file, please proceed to click on it once more in order to extract its contents. Inside of it, you will find a folder named specifically as Adafruit motor. Please copy this particular folder and paste it into your designated rival folder located on whichever drive our CircuitPy device is currently connected onto, just as you did before when downloading it. This action will prepare everything needed for us now. Now then, I shall open up our previous session's code from last time around, delete all existing lines of old code there, and input entirely new lines of fresh coding instructions instead. In those older versions containing CircuitPython examples previously available back then, there were indeed some example cases which utilized PWM out sourced directly from Pulse.io. However, though, attempting such usage within these current circumstances would unfortunately result only in an error message being displayed. So you can simply read the PWM out from the PWM IO side here. To begin, you need to import the necessary modules, specifically the servo and PWM, from the library known as Adafruit. This is essential for controlling the servo motor. Next, you will set the PWM out cycle to 0, which means that initially there will be no output signal. Additionally, set the frequency to 50, which is a standard frequency for servo motors. Now, create a servo instance, which we will call servo1. This instance will be associated with the PWM instance you have just set up. When creating this servo instance, it is crucial to set the min pulse to 500 and the max pulse to 2500. These values are fixed and are necessary for the proper functioning of the servo motor, as they define the range of pulse widths that the servo can interpret. Therefore, input these values exactly as specified. Moving on, you will implement a while true loop. Within this loop, the angle of servo1 will be controlled. The loop will adjust the angle every second to specific positions, starting at 0 degrees, then moving to 45 degrees, followed by 90 degrees, then 135 degrees, and finally reaching 180 degrees. This sequence of movements allows for a comprehensive demonstration of the servo's range of motion. By following these steps, you ensure that the servo motor operates correctly and efficiently, providing precise control over its movements. Let me check it once. As you can see, the servo motor is moving, and this is 0 degrees. This is 180 degrees. You can control the servo motor like this at angles of 0, 45, 90, 135, and 180 degrees. In this session, I worked on controlling a servo motor with CircuitPy. I will see you next time with different content.